Hey NCU students. Hey, case study 6 was a little bit confusing in some areas, so I kind of rewrote it to help clarify a little bit better. One of the things I wanted to point out was, for example, the wording on sampling error is really nothing more than what we're looking for is just taking the difference between the population mean and the sample mean and discussing that difference. So compare the sample mean to the population mean, take the difference, observe that gap that's between the two of them, observe how close or how not close they are to each other. And the whole purpose is to help you understand that the sample, if it's small, may not produce a good sample. And that repeated sampling with a small n doesn't necessarily make you get better or worse. If you really want to get closer to the population mean, then increase the size of your sampling so n gets bigger and bigger and bigger, and that'll give you a much better a much better sample mean compared to the population. The gap will be smaller. However, more sampling means more cost, so that's one of the trade-offs. Number 2, and I'm going to send this file to you to be in the announcements section as well, but number 2, I changed up the order of this used to be B and now it's A. So I'll create a new column out there called satisfaction level. You know, it's probably best to use like 1 to 5 because there's 5 different categories of satisfaction. So label them 1 to 5, put a new column in there, 1 to 5 for each of the different ones. Then start doing the random sampling and calculating the sample mean. So you're calculating the sample mean of the satisfaction level, not the customer number, okay? And take a look at what does that thing really mean to you? What does that satisfaction level mean to you? And excuse me. And then again, interpret the results in light of the differences between the sample mean and the population mean and the size of the sample. Let's see, number 3. Listen, 3A and 3B are all about building the sample table. Okay, so let me just walk you through it real quick. The first question says how many different samples of 3s are possible. Well, this is a table size of 6, and you're going to choose as many of 3 as you can out of there, 3 unique. So it's a 6 choose 3 combination problem. And if you Google search that or look that up, it's going to lead you down the right path. So basically the table size is 6. You're going to choose as many unique combinations of 3 from that table that you can. Now I'm going to tell you the answer, it's 20. But you got to do the math, okay? And hint, you can find a real simple function for this inside of Excel. So it's a 6 choose 3 combination problem. It's going to give you the answer of 20. So your list of samples is going to be 20. Let's talk about B for a second. So what you're going to do is, now that you know that there's going to be there's 20 different sampling combinations of 3 unique companies in each sample, you need to generate that list. So sample 1 is going to be 3 different companies. Sample 2 will be another 3 different companies, etc. There'll be 20 of them. For each of those samples, find the mean. Okay? So you're going to have 20 different means lined up for 20 different samples, and then you're going to do C, was comparing the sample means to the population mean. All right, hope that's helpful. And if you have any questions, make sure to email me, or if you need to Zoom, let me know that as well. All right, thanks.